When sizing a disconnect for a multi-motor or compressor chiller, adherence to the National Electrical Code, or NEC, is paramount. The NEC mandates that the disconnect be sized at a minimum of 115% of the chiller's minimum circuit capacity, commonly referred to as the MCA. This requirement ensures that the disconnect has sufficient capacity to handle the potential load of the chiller without risk of failure. The question at hand involves a chiller with an MCA of 383 amps. To determine the appropriate disconnect size, we must calculate 115% of this value. Performing the calculation, 115% of 383 amps yields 439.95 amps. This figure represents the minimum amperage rating required for the disconnect. A common question arises regarding whether our 400 amp disconnect would suffice in this scenario. However, based on the NEC stipulation of 115% of the MCA, a 400 amp disconnect is insufficient. It falls short of the calculated minimum requirement of 439.95 amps. Therefore, selecting a disconnect with a rating lower than this value would be a code violation and could potentially lead to safety hazards. In practical applications, disconnects are available in standard sizes. The calculated value of 439.95 amps does not correspond to a standard disconnect size. Therefore, it becomes necessary to select the next standard size disconnect that meets or exceeds this calculated value. In this case, the closest standard disconnect size to 439.95 amps is 450 amps. Selecting a 450 amp disconnect ensures compliance with the NEC requirement of 115% of the MCA and provides an adequate safety margin for the chiller's operational demands. It is crucial to understand that the NEC requirements are not arbitrary but are based on sound engineering principles and safety considerations. The 115% rule is intended to account for factors such as motor starting currents, which can be significantly higher than the running current, and potential voltage fluctuations that can increase the current draw. By sizing the disconnect appropriately, we minimize the risk of overheating, nuisance tripping, and equipment damage. Furthermore, selecting the correct disconnect size is not merely a matter of code compliance but also a matter of professional responsibility. As electrical professionals, it is our duty to ensure the safety and reliability of electrical systems. Proper disconnect sizing is a fundamental aspect of this responsibility. Failure to adhere to the NEC requirements can have serious consequences, including electrical fires, equipment failures, and even personal injury. In addition to the 115% rule, there are other factors to consider when sizing disconnects. These include the type of motor, the ambient temperature, and the altitude. Motors with high starting torques or frequent starts may require larger disconnects to accommodate the increased current demand. Ambient temperatures above or below the standard rating of the disconnect may also necessitate adjustments to the disconnect size. Altitude can also affect the performance of electrical equipment, particularly at higher altitudes where the air is thinner. In such cases, steering factors may need to be applied to the disconnect size. To ensure accurate disconnect sizing, it is essential to consult the NEC and other relevant standards, such as those published by the National Electrical Manufacturers Association, or NEMA. These standards provide detailed guidance on selecting the appropriate disconnect size for various applications. It is also advisable to consult with a qualified electrical engineer or inspector to ensure that the disconnect sizing is correct and in compliance with all applicable codes and regulations. When selecting a disconnect, it is important to consider not only the amperage rating but also the voltage rating, the interrupting capacity, and the type of enclosure. The voltage rating of the disconnect must be equal to or greater than the voltage of the circuit it is protecting. The interrupting capacity of the disconnect must be sufficient to interrupt the maximum available fault current at the installation location. The type of enclosure must be suitable for the environment in which the disconnect will be installed. For example, in wet or corrosive environments, an M4 or forks enclosure may be required. The installation of the disconnect must also be performed in accordance with the NEC and other applicable standards. The disconnect must be installed in a readily accessible location and must be properly grounded. The connections to the disconnect must be made with appropriate connectors and must be tightened to the specified torque. After the disconnect is installed, it is important to test it to ensure that it is functioning properly. The test should include a visual inspection, a continuity test, and an insulation resistance test. Any defects or abnormalities should be corrected before the disconnect is put into service. Regular maintenance of the disconnect is also essential to ensure its continued reliability. The maintenance should include periodic inspections, cleaning, and tightening of connections. Any worn or damaged part should be replaced promptly. By following these guidelines, we can ensure that the disconnect is properly sized, installed, and maintained, providing reliable protection for the chiller and minimizing the risk of electrical hazards. In summary, when dealing with a multi-motor or compressor chiller having a minimum circuit ampacity of 383 amps, a 400 amp disconnect will not suffice. The National Electrical Code mandates sizing the disconnect at 115% of the minimum circuit ampacity, resulting in a minimum requirement of 439.95 amps. The closest standard disconnect size that meets this requirement is 450 amps. Therefore, a 450 amp disconnect is necessary to ensure compliance with the NEC and provide adequate protection for the chiller. It is important to remember that the NEC requirements are based on sound engineering principles and safety considerations, and adherence to these requirements is crucial for ensuring the safety and reliability of electrical systems. Failing to comply with the NEC can lead to serious consequences, including electrical fires, equipment failures, and even personal injury. Always consult the NEC and other relevant standards, such as those published by the National Electrical Manufacturers Association, and consult with a qualified electrical engineer or inspector to ensure that the disconnect sizing is correct and in compliance with all applicable codes and regulations. By following these guidelines, we can ensure that the disconnect is properly sized, installed, and maintained, providing reliable protection for the chiller and minimizing the risk of electrical hazards. Always prioritize safety and compliance when working with electrical systems. Remember that electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. If you are not qualified to work with electricity, seek the assistance of a licensed electrician. In addition to the NEC requirements, it is also important to consider the manufacturer's recommendations for disconnect sizing. The manufacturer may specify a larger disconnect size than the NEC requires, particularly for chillers with high starting torques or frequent starts. Always follow the manufacturer's recommendations to ensure that the disconnect is properly sized for the specific application. Furthermore, it is essential to consider the environmental conditions in which the disconnect will be installed. If the disconnect will be exposed to extreme temperatures, humidity, or corrosive substances, it may be necessary to select a disconnect with a higher amperage rating or a special enclosure to protect it from the environment. Regular inspections and maintenance of the disconnect are crucial for ensuring its continued reliability. The disconnect should be inspected periodically for signs of wear, damage, or corrosion. The connection should be tightened to the specified torque, and any worn or damaged parts should be replaced promptly. A well-maintained disconnect will provide reliable protection for the chiller and minimize the risk of electrical hazards. In conclusion, sizing a disconnect for a multi-motor or compressor chiller requires careful consideration of the NEC requirements, the manufacturer's recommendations, and the environmental conditions. By following these guidelines, we can ensure that the disconnect is properly sized, installed, and maintained, providing reliable protection for the chiller and minimizing the risk of electrical hazards. Safety and compliance should always be the top priorities when working with electrical systems. Selecting the right disconnect involves a few crucial steps. Firstly, identify the chiller's minimum circuit ampacity, which is typically found on the equipment's nameplate. Secondly, calculate 115% of the MCA. This value represents the minimum amperage rating required for the disconnect. Thirdly, choose the next standard disconnect size that meets or exceeds the calculated value. It's important to remember that disconnects are available in specific standard sizes, so you might need to round up to the nearest available size. Finally, ensure the selected disconnect meets or exceeds the voltage and interrupting capacity requirements for the chiller's electrical system. Remember to verify all local codes and regulations that might have additional requirements beyond the NEC. Always consult with a qualified electrician or electrical engineer if you are unsure about any aspect of disconnect sizing. They can provide expert guidance and ensure that the installation is safe and compliant. Furthermore, it's vital to maintain proper documentation of all electrical work, including disconnect sizing calculations and installation records. This documentation can be helpful for future inspections, maintenance, and troubleshooting. Proper documentation demonstrates a commitment to safety and compliance and can protect you from liability in the event of an electrical incident. Disconnect sizing isn't just a technical task, it's a critical safety measure. A correctly sized disconnect protects the chiller from overcurrents and short circuits, preventing equipment damage and potential fire hazards. It also provides a safe means of disconnecting power to the chiller for maintenance and repairs. By taking the time to size the disconnect properly, you're investing in the long-term reliability and safety of the electrical system. Consider the following scenario: a chiller with a minimum circuit ampacity of 300 amps requires a disconnect. Following the 115% rule, the minimum required disconnect size is 345 amps. In this case, a 350 amp disconnect would be the appropriate choice. The 350 amp disconnect exceeds the calculated minimum requirement and provides adequate protection for the chiller. Conversely, a 300 amp disconnect would be insufficient as it falls below the calculated minimum. Another consideration when sizing disconnects is the ambient temperature. Disconnects are typically rated for a specific ambient temperature, typically 40 degrees Celsius or 104 degrees Fahrenheit. If the disconnect is installed in an area with higher ambient temperatures, it may be necessary to direct the disconnect's amperage rating. Dirting involves reducing the disconnect's amperage rating to account for the increased heat. Dirting factors are typically provided by the disconnect manufacturer. It's crucial to consult the manufacturer's specifications to determine the appropriate dirting factor for the specific disconnect and ambient temperature. In addition to ambient temperature, altitude can also affect the performance of disconnects. At higher altitudes, the air is thinner, which can reduce the disconnect's ability to dissipate heat. This can lead to overheating and premature failure. Disconnect manufacturers typically provide altitude correction factors to account for the reduced cooling efficiency at higher altitudes. These correction factors are used to adjust the disconnect's amperage rating based on the altitude of the installation. Furthermore, it is essential to consider the type of enclosure used for the disconnect. The enclosure protects the disconnect from environmental factors such as moisture, dust, and corrosion. The type of enclosure required depends on the environment in which the disconnect will be installed. For indoor applications, an NEC enclosure may be sufficient. However, for outdoor applications or in areas with high moisture or dust levels, an NEC 3R or 4 enclosure may be required. In corrosive environments, an NEC 4 enclosure made of stainless steel or fiberglass may be necessary. The enclosure should be properly grounded to ensure safety. The grounding conductor should be sized according to the NEC and should be connected to a suitable grounding electrode. Additionally, it's vital to use appropriate connectors and conductors when installing the disconnect. The connectors should be UL listed and rated for the amperage and voltage of the circuit. The conductors should be sized according to the NEC and should be suitable for the application. All connections should be made tightly and securely to prevent overheating and arcing. Always follow the manufacturer's instructions when installing the disconnect connectors and conductors. It is also crucial to label the disconnect clearly and accurately. The label should identify the equipment that the disconnect serves and the voltage and amperage of the circuit. The label should be durable and easy to read. Proper labeling helps to prevent confusion and ensures that the disconnect is used correctly. Finally, it's recommended to perform regular maintenance on the disconnect to ensure its continued reliability. Maintenance should include visual inspections, cleaning, and tightening of connections. Any worn or damaged parts should be replaced promptly. Regular maintenance can help to prevent failures and extend the life of the disconnect. In summary, sizing a disconnect for a multi-motor chiller involves several factors, including the minimum circuit ampacity, ambient temperature, altitude, enclosure type, connectors, conductors, labeling, and maintenance. By considering all of these factors, you can ensure that the disconnect is properly sized, installed, and maintained, providing reliable protection for the chiller and minimizing the risk of electrical hazards.